Hey, hi everyone. I also parallelly shared my screen. Um, Vignesh, could you confirm if my screen is visible?
Yes, sir, it's visible.
All right, sure. Can we start the session or should we give a minute or two for the folks to join in? Hello, Vignesh.
Yes, sir.
Yeah, I was just asking, could we start this session or should we give a minute or two for the students to
You
dial
can
in?
you can start, sir.
Okay, okay. All right. So first of all, good evening, everybody. So today's session is going to be about the art of storytelling, how a raw data gets transformed into actionable business insights. I would first like to thank IIT Madras Management and NPTL program for giving me this opportunity, especially Florence and Vignesh, who have been coordinating with me for this presentation. And also, I would like to thank PayPal for collaborating with educational institutions like IIT Madras and helping students to upskill and gain a different perspective, industrial perspective of data science and things like that. First, yeah, thanks IIT Madras, PayPal, and NPTL for this opportunity. Having said that, I'll start my session. First, I'll give a quick introduction about myself. Myself, Ajit, I am currently a senior business intelligence analyst at PayPal. I have over 6 years of experience, specifically in data science field. As soon as I graduated, I kickstarted my career into data science field. Over this span of 6 years, my expertise and experience lies in business intelligence, performing data analytics, particularly in the fields such as fintech, healthcare, and e-commerce domains. Outside of work, I have also trained multiple folks. When I was employed in my previous organization, Music Mom, I had acted as a trainer and I had trained multiple data science professionals in problem solving and upskilling themselves in Python. In addition to that, I have also led teams for delivering data science solutions, wherein my client included Fortune 500 companies. I also have an hands-on experience across tools, across visualization tools such as Tableau, Looker, ThoughtSpot, and of course BigQuery and SQL, which we use for querying the databases. In addition to data science tools like Python, wherein we perform our modeling and all other data science projects. This is about me. Um, Now I will set the expectation of this session. I am more interested in for me, expected outcome is more important than the agenda of a session. So what I'm targeting by the end of the session is the students or the audience should be able to comprehend the data transformation journey. That is how a raw data gets transformed into a business decision, which ultimately flows back into our lives. Correct. That is first expected outcome. The second is, in this 1 hour of session, we'll not be able to go deep into the technology, coding, things like that. So at least I wanted to give an overview of what are the technologies which we use in our industry uh, for this data journey, to accelerate or assist this data journey, which lies right from raw data to how business decisions are made. Then I would, this is a theoretical session, post which I would encourage the audience to go and implement this in real life cases. Even if you are a student, right, there are various data which is available online for free, like platforms such as Kaggle or Analytics Vidya. They have some sample data sets which you can leverage and try to create solutions for the problem statements that lie there. Then At whatever stage of life we are, we should have a mindset of continuous learning and upskilling. That is one more thing which I'm targeting, to leave you with a mindset of continuous learning and upskilling. At no point of life it's like we have become an expert and our upskilling is done. No, that is not the case. We should always quench, we should always be curious and try to learn many things, attend various webinar sessions, try to have the continuous learning mindset. This will take us a long way in our career. um, Moving on to the next slide. So the agenda here, I'll not spend much time here because the mostly the agenda will get covered in the data journey once again. Just bucketing the agenda here, I'll just start with providing an overview of the data journey. Then I'll be talking about details about each step in the data journey, right from data collection to data visualization and insight generation. Then I have three case studies with me, which I'll be providing you a walkthrough on. Then I'll open the floor for Q&A. Okay, moving on to the next slide, which is data journey. Um, so one thing I would like to call out, there is no one data journey that would fit for all the problem statements. So each domain, what do I mean by domain? We have verticals, business verticals like pharmaceutical verticals, e-commerce vertical, or even financial fintech verticals, things like that, right? Each business will have their own problem statement, and each problem statement solution is unique enough, just like how our DNA is unique for every individual. The solution for each problem is also very much unique. So it is not necessary that all the solutions will follow in this route which I'm going to tell now. Each one will have an unique journey, and some of the processes which I am going to tell here might also get bypassed based on the problem statement. But what I'm trying to bring here is a common data journey which might fill into a lot of problem statement bucket. Okay, so first it starts from data collection. Uh, then data collection, as the name suggests, it is all about collecting data from various platforms or various processes, right? Then engineering the data so that it is hosted in a cloud server or a technique or a physical warehouse, things like that. Then doing pre-processing on top of the engineered data, then performing exploratory data analysis on the pre-processed data, then performing feature engineering, modeling the data, visualizing, and trying to generate insight out of it. I will spend time on each of these processes in my upcoming slide, but I just want to move forward with the next slide, leaving the this thought here. So this data journey is going to be unique, and it is going to be problem specific. There is no one data journey that would fit all the problem statements. Okay. We'll start with data collection. Okay, data collection, each industry will want different type of data, right? I will, in my slide, I have given example of retail, healthcare, and financial services. Retail services will be interested in collecting sales data, customer feedback related data, things like that. E-commerce might be interested in collecting data about posts, comments, and whatever is available in the social media like Facebook or Instagram, to get the sentiment about their products or things like that. Here I'm just giving you a use case, right? Okay. Then moving on to the healthcare industry, they will be collecting patient related records, maybe their insurance schemes which they are enrolled to, then some sensor data. And for clinical trials, they will be collecting the data on the onset of diseases, how many patients are actually suffering from such diseases, things like that. Then financial services would like PayPal, right? Since I'm from PayPal, we collect transaction related data, market trends, economic indicators. Then the obviously the sentiment of the customers, right? How positive are they to our products, and also the data which will measure the success of our products, correct? We obviously launch various features into the market. We wanted to understand how was the success rate of those products and things like that, right? So such data would be collected. One important thing is that at any point of time, personal or sensitive data will not be collected unless and until there is a consent from the individual. You would have already seen when you are utilizing some of the products from YouTube or Facebook. Initially, when you log into the product, you will be asked for a consent. These are the data which we would be collecting, and are you fine with it? Only with whatever data is being consented, only that will be collected, because following the ethical reasons, right? Okay. Now, you got an idea of what are the different types of data that is getting collected. Now, what are the technologies that will help to collect these data, or to store this data in a structured way, right? So, DBMS systems like MySQL, PostgreSQL, Oracle, obviously will help us to store the data in a structured way. Then there are big data technologies. Now you know this, right? The data volume is growing rapidly. Every organizations wants to perform analysis on top of the data, and every hour, even as we talk, right, the data is getting generated, right? In order to enable and process this at a scale, big data technologies such as Hadoop, Spark help institutions. Then web scraping tools. So we have Python libraries such as Beautiful Soup, Scrappy, which will help us to extract data from websites for analysis. We also have APIs that will allow data retrieval from various platforms like social media or financial services. Now, there are IoT devices which will collect sensor data for real-time monitoring and processing. So this is primarily used in healthcare industries, wherein there are sensors on patients in order to monitor their health performance, things like that, right? Finally, we have cloud platforms such as AWS, Azure, and Google Cloud, which will offer and process big data. I hope things are clear here. I'll move on to the next slide. I'll pause for a moment here, and if you have any questions, I'll just take up. Vignesh, could you confirm if we have any questions? If no, I'll proceed with the next slide.
We can proceed, sir.
Okay, thank you. Next is data engineering. So now that the data has been collected from various sources, uh, it is still a raw data. We will not be able to generate any insights or analysis on top of that, right? First, it needs to be engineered. What do I mean by engineered? It needs to be extracted, transformed, and loaded to a particular data warehouse. So extraction is nothing but when we have multiple data sources, sometimes like APIs, files, or even web streams. They're all at multiple data sources, and it will have their unique data type. Some might be a text related data, some might be in a video format, right? So all those data needs to be extracted, transformed, and loaded to the system. So during this phase, we will provide the metadata information. So, like, what should be the data type of the data that is going to be loaded? If it is going to be a numeric ones, obviously we will provide the metadata as integer or float. Again, it depends upon the ETL engine which we are going to do this process. Okay. To aid this, again, we have big data technologies such as Google Cloud, Azure, AWS. The reason why we are moving on to big cloud storages, it is because they offer distributed computational service, and also data storage. obviously much better than what traditional warehouses such as Teradata or things like that was offering. And also these big data will enable us for real-time data processing. Okay, so just summarizing this slide, data engineering is nothing but performing an ETL on top of raw data that has been acquired from various data sources. Again, here one thing we'll have to keep in mind is data engineers just don't perform ETL processes, and it's not that one time when this ETL processes is done, their job is completed. It is not going to be like that. Here also, it has its own technical nuances and challenges, and it's not one time ETL which will means that okay, the organization will have all the data. So you know that the data is being collected and generated on daily basis, so all these ETL jobs needs to be ran at daily basis in order for the big business institutions to make use of these. Okay. um, okay, moving on to the next slide, which is data pre-processing. Now that we have data in some place, in some data warehouse, so again, at least in PayPal, right, now we are moving on to Google BigQuery or Google Cloud, which is where we are hosting the data. One more thing is, while hosting the data, or when the data engineers are engineering the data into these warehouses, they need to use the efficient querying techniques while creating those data tables. Because the data size is very high, we deal with billions of records, correct? If at all the data table is not created in a way, it is not optimized, querying on top of that, or even doing basic pre-processing on top of the data table is going to be very challenging. So there are some optimization techniques and query tuning techniques which needs to be followed while building the table. So few I can just call it out, and you can research more about it. Like at least in BigQuery tables, right? We use clustering and partition by. This will ensure that when the data table is getting created, the similar records are partitioned into a particular area, which will ensure that when we are trying to retrieve the data, the scanning in the entire table is going to reduce significantly. If we don't introduce this partition or clustering in our data tables, whatever querying or pre-processing we are trying to do on top of this table will take a significant amount of time. Once it is partitioned and clustered properly, we can see a drastic reduction in the time which it takes for querying the data. Okay. Now I will start on data pre-processing. Okay. Once now the data has been loaded, do you still think it will have the data in a very good format so that it can be consumed? No, that is not going to be the case. There are chances that it will have outliers, right? Because there are chances that it will have missing values in it. Correct. So all these things needs to be handled in the initial place. The reason being, if the missing values or outliers are not handled properly, the model which we are going to build on top of this later is not going to be an accurate model. It might get overfit, or it might get biased to a certain trend, which will not be an expected outcome, and which will result in inappropriate business decisions and insights, right? So this is the fundamental step, cleaning the missing values. There are various ways to clean the missing values. So some of the commonly used ways which I am using in my project is to replace the missing value with summary statistics like mean or median at times. But one more thing you'll have to keep in mind here is that there is no one method which will fit for all the business use cases. We must have a good domain knowledge while doing these. Maybe for some domain or some business use cases, okay, just replacing the missing value with some summary stats like mean should be enough. But that may not be the case for some other business use case. Then same with removing outliers. Why do the outliers first of all come into the data? It comes for various reasons, right? Sometimes it is just an error in which has happened just because the data has got loaded to the system. or it is an error in the measurement which we have taken, because of which these outliers might get embedded into our systems. This again needs to be removed. I will give you an example here. Imagine a scenario wherein there is a customer, okay, for a financial services, assume just like a Google Pay or PayPal. He has been doing $50 transaction on a daily basis, somewhere around $50, or the range is just 50 to 100. This has been a trend. But all of a sudden, there is a spike. We see a $5,000 transaction on a particular day. Can we just call this as an outlier? Again, this depends on the business use case and question. Maybe it is not an outlier. This has just happened. Maybe this is a fraudulent transaction. This one was for some unethical reason. This amount has got transaction which is irregular from his usual transaction. But this can also be for a genuine cause. Maybe there has been some emergency. For availing some emergency service, the this amount has been transacted, right? So we can take both these sides of the story. What I'm trying to tell here is that we need to be conscious on bucketing that as whether that is an fraudulent or non-fraudulent, or outlier, or not an outlier, things like that. Okay. So here some of the technologies which we are using for doing these data pre-processing. In Python, we make use of pandas, scikit-learn, and numpy libraries. In R programming, again, we have packages like dplyr. We can also perform data manipulations in Excel. The only limitation is that the amount of volume which Excel can handle, that is going to be limited, right? That is why we are looking for big heavy technologies like cloud technologies like Azure, AWS, Google Cloud, etc. I hope you are clear on data pre-processing. I'll just quickly summarize this slide. Pre-processing is very important before performing any modeling or bringing out insights. The very reason being, this might inject junk data and might distract us from what we are actually targeting. Okay. Next comes the exploratory data analysis. What do I mean by exploratory data analysis? Now that we have you remember, right, how our data was? It was in a very raw state. It was lying here and there at various places. Then we engineered it and brought into a system by building appropriate queries and building robust tables. Then we identified there are some missing values, there are some outliers. We did necessary treatments for that. Are we Do you think the data is still good for analysis? No. The reason being, okay, we have data in some raw format. Raw format as in it is there in some table, or it is just hosted in some places, and basic cleaning is done. But we will have to see what information is my data capable of giving. Can I see some trend? Can I see some historic trend, or can I do some retrospective analysis? Will I be able to segment some of the data points? All those things can be done in this exploratory data analysis journey. Here, you can get the summary stats of the data, right? Here, you will be able to see the distribution of the data. How was it distributed? Is it a normal distribution, or things like that, right? So from this, you will be able to see the trend, previous trend. I'll just give you an example. You're just plotting the sales of a particular product, even in, just assume for PayPal, right? We are just plotting the sales of particular product in the last 1 year span of time. We are seeing spikes in specific intervals. Okay, this is just the thing which we have got from data on doing EDA. Okay, we know that we plotted some graph and there are spikes at different intervals. Later, we will go and deep dive and see on what intervals these spikes had happened. Then we will see, okay, on those dates we had festivals or celebrations like Christmas coming in, because of which the sales had spiked up. So all these insight gathering will happen later, but EDA will set the foundation for doing that, just plotting the trend and getting an idea of what your data is trying to tell. This is one aspect of looking into exploratory data analysis. The second thing is performing correlations. So why this correlation is important? Maybe two metrics are directly correlated to one another. I'll just give you an example of a pharmaceutical industry, wherein they are trying to build oncology drugs to reduce the impact which cancer is creating on humans. There they collect the data, right? There they see blood pressure is related to the onset of a disease. So which means that blood pressure is a column which we are gathering from patient, right? And we are also capturing the onset, whether the patient is getting diagnosed by a particular disease or not. That in another column we directly see a direct correlation between these two. When one field is spiking, there is a spike in another field also. What does that convey? This conveys that both these columns are related to one another. So later when we are performing modeling, it is not needed that we will have to introduce both these features to our model. The simple reason being the models will get biased towards these features, or it will get overfit. So that is why correlation analysis is important. We need to identify which fields are related to one another. Things like that. Okay. Then again in EDA, we, as I was telling, right, we will try to see the groups, what age group of customers are actively buying the products from PayPal, right? These segmentation is something again we'll get from doing an EDA on top of the data. Then again, pattern recognition, as I was just talking earlier. And again, the technologies, mostly it is Python libraries. Again, pandas, and you can use matplotlib and seaborn for performing for seeing the data or visualizing the data. Then again, our programming has its own libraries. Tableau and Looker are some of the interactive tools which even I am using in my daily projects to understand the trends and trying to generate insights out of it. For a beginner, if at all you don't have access to any of these platforms, obviously you can try to download small data sets from free available platforms in online and do the analysis in Excel. Even Excel supports various visualizations and things like that to perform these basic EDA. Hope you're clear about EDA. I also covered the importance of EDA because I'll quickly summarize it. The EDA is where we will try to identify a pattern or trend on whatever data we have. This is fundamental for making modeling decision. It also uncovers data quality issues and helps us in refining processes. This will aid us in data-driven storytelling and decision making. Uh, I'll just pause for a moment here to see if there are any questions. If no, I'll proceed to my next slide. Vignesh or Florence, do we have any questions or can we proceed?
You can proceed, sir.
Okay, thanks. Thank you. Next comes the feature engineering. Feature engineering is the fundamental thing before doing data modeling. Why is it important? Feature engineering will help us to create models that are robust enough, which are more interpretable, and which will give us a meaningful pattern out of the models, and also for computational efficiency reasons, because of which feature engineering is of utmost importance. This I just covered why it is important. Now I will talk about what exactly is this feature engineering, right? So again, one thing which we'll have to keep in mind, it is very problems space specific and domain specific. So feature engineering is nothing but selecting and transforming the variables in a way that it can be read by machine learning models. It basically bridges the gap between the raw data, or at least to some extent cleaned data, to the to a place where a machine learning model can communicate it. Okay. So there are models which will only take in numerical variables. But if you see the system, we will be feeding in even categorical variable. For example, the gender of an customer, right? It is a categorical variable, like it is male or female. It usually comes in text or string format, but it may not be convenient for a model to extract or to do analysis on the categorical variables like gender or things like that. At such cases, what we can do is, if we can basically encode the categorical variables to numerical variables, either we can assume labels, we can just assume in a non-orderly fashion like one or two, or we can do one hot encoding, basically making male, whenever there is a male entry, creating one column for male and one more column for female. If it is a male, it will become 1 and 0. For a female, it will become 0 and 1. Things like one hot encoding, which can be done using encoding categorical variables. Then the second thing is normalizing. So there are various data fields, right? Each data field will have its own range. For one field, maybe for sales, the range may be very different. It might be in thousands, but the range for some other field, just like the number of products, that may not be in the same scale as how the range for sales is, correct? So how do we give equal? How do we prevent one field dominating the other field just because the values which is getting stored in one field itself is significantly high compared to the other field? In such cases, normalization comes to help us, right? So basically, we can make the features within a similar range, basically between 0 or 1, in order to prevent one feature dominating over the other feature when we are trying to perform modeling on top of that. This is about normalization. Then comes about feature scaling, right? So again, even here, we try to make a similar scale. For example, making the features to a standard deviation of 1. This gives equal opportunity for all the features which we are using. Then dimensionality reduction. One aspect of it I had already covered during EDA, that is correlation. So if you find that two features are dependent over one another, then there are chances that you can go ahead and remove a particular feature. Again, even here we have to take utmost consideration from the business stakeholders on identifying if these features are not relevant for the business, or things like that, because this is all very much problem specific and domain specific final decisions which we will have to take during feature engineering. I will quickly summarize this feature engineering slide. So I told you it basically bridges between where the data is and to a place where machine learning models can read the data. I covered commonly used feature engineering techniques such as encoding categorical variables, normalization, feature scaling, dimensionality reduction. This is very important. This will give integrity on the model. We will be able to build robust models, and also the computational efficiency on the models will become significantly high when the data is properly feature engineered. Uh, Moving on to the next slide, which is data modeling. Data modeling itself is a very vast topic, and we cannot, in this particular duration, right, we will not be able to dwell into the various types of data modeling. So what I'll be covering here is the data modeling journey itself, how the data, how does a model get deployed to a server from where it started from raw data. Okay. So you remember the data journey we have traveled so far. So first, it was data collection which we did. Post data collection, we performed engineering on top of that. Then we did some pre-processing, like handling outliers, missing value statement, etc. Once that is done, we try to do some exploratory data analysis on top of the data and trying to get some trend. Once that is completed, we did a feature engineering so that our data is in a good shape to get communicated with the data model. This is the journey we have come so far. So this data modeling, right? It starts from defining the objective. First, it is very important to understand the problem statement and objective of the analysis. So, if the problem statement is done, it's like almost we have reached to 70% or 80% of approaching the solution. Okay, once the data statement is defined, we need to identify the right data sources. Correct. For example, I'll talk about this during our case study discussion also in the upcoming slides. So it is important to identify the right tables which is needed for my data models, and also and also we have to ensure that the data tables which we are using is properly optimized and built in efficient manner. Then comes preparation of data, which we did like do in feature engineering. We basically need to convert categorical variable into a variables that is interpretable by the data models. Then algorithm selection. So you might be knowing machine learning has different types of models, one being supervised, unsupervised, things like that. And again, with supervised and unsupervised, it itself has a lot of different types of models. So based on our problem statement, we need to classify, like there are if your problem statement is just classifying fraudulent transactions and non-fraudulent transaction, this will fall into a classification bucket. So the models that supports classification related for problems needs to be taken care. Then training the model, testing the model. So training, we feed in some sample data with necessary parameters for our model to learn from the data which we are feeding in. We again have our industry practices like 80% falls into training, 20 into testing, 70/30. Those rule again, it will go with each business use case. So once training is done, again here you will see the model parameters, you will see the accuracy of the model, and again various related parameters depending upon the models. Then you will test on top of the trained model. Again here you have to be very cautious that your model does not become overfit or biased. If at all your model is giving like 100% accuracy or 99% accuracy, there are high chances that your model is overfit. What does this overfit mean? It will, your model will only work for the data which is similar to the model which you have fed in the training data set. But in real life, when you integrate this model, your data is not going to exactly match what you have fed to the training model, right? It will vary. It will vary on daily dynamics. And even in those scenarios, your model should work. That is why you'll have to take into consideration the accuracy. Shouldn't your model should not be overly fit or underly fit also. It should be in an optimal level. Okay. Once all this modeling is done, we have to deploy it or in the production server for our daily consumption. Uh, I'll move on to the next slide. Okay, this is a very interesting topic, which is about visualizing the data. We saw the data, you saw, right? The data was there in EDA. It was there, it was featured and feature engineered, then modeled. Even the model data, okay, you model the data in order to do something. Okay, maybe in order to see if your algorithm can, for example, I'm just giving you an example. If your algorithm can improve the user retention in a particular app, like for example, PayPal. Now you'll have to see whether it is really doing the purpose, right? So you can see the previous trend how it was, and using interactive dashboards you can show after deployment of the model how this trend has changed. Has it changed in a direction where it is in the expected range for the business leaders, right? And business decisions can be easily taken when you have proper visualizations or interactive dashboards built for the business leaders. Again here, over the period of time we were trying to build interactive dashboards. So obviously when one way is ppt, we can build graphs and things like that, but the limitation is the amount of data which it can handle, and the real time updating or refreshing that happens in the ppt or things like that, it is going to be difficult. Because of which nowadays interactive dashboards are there, like tableau or looker, which can connect to cloud data sources like BigQuery, AWS, and things like that, and can provide interactive visualizations. By this, the complex data set will get consumed in a manner, or will get displayed in a manner that it is readable for the business leaders to make a decision out of it, right? And now the some of the tools which we are using is Looker, Tableau, Power BI, ClickSense. Yeah, this is about data visualization. This was the trend earlier. Now with the Gen AI coming into place, right? We are trying to build customized or personalized dashboards for the business leaders. Each leader will have their own request, or they may be interested in seeing their own data which is relevant for them. So it might be difficult for the business developers to create one visualization which will suffix the use case for all the end users. So in those cases, what can we do? So what we're trying to do here is to try to build self-serve products. So Looker is one such tool which is enabling us to do it. So what we're doing here is we are enriching them with data. Obviously, billions of record, we are trying to bring it in a user interface, and just by doing some simple drag and drop options, they can build their own custom visualizations which will enable them to build business decisions. So in this approach, lot of things will get eliminated. The dependency on the business on the dashboard developers to create dashboards, and if at all there are some ad hoc requests which these business leaders wants to see, right? Suddenly they want to deep dive and see, okay, why there was a dip in a particular product for this period of time. They may be reaching out to analytical teams to analyze why this trend was happening. This can be completely eliminated with self-service tool. Now they themselves have the capability of drill down and talking to the data and identifying why the trend is going up or going down, things like that, right? That is where these new technologies like Gen AI, things like that is coming for our support. Uh, okay, this is about data visualization. Lastly, I will provide you a walkthrough on real life studies. Now that you understood the data journey, how it starts from simple data collection to how it got visualized, and how business leaders will try to generate insights out of it and make business decisions, right? Now I'll give you a real life example. One is airline flight delay prediction. Okay, this is for an airline industry. Here the business problem is they want to minimize the flight delays. So the first step, how do they do it? Obviously the data needs to be collected, and ETL needs to be done on top of that. So they gather flight data from various sources, they ingest weather data, airport data to the data warehouse, which moves to the next stage wherein the analyst comes in, takes it up, see if there are missing values, see if there are duplicates, see if there are outliers, treat it, then just generate data summary on top of it. Then comes feature engineering. There might be categorical data which will get encoded in feature engineering phase. Then a model, a test and trend predictive delays model is being built. Again, here appropriate algorithm needs to be taken care. Um, Once the model is built, we can plot visualization and see has the trend improved over the period of time. We can also have a separate visualization to visualize the weather impacts which is there at various airports. Once this is done, we try to generate insights like predict likelihood of delay. Like, okay, most likely if the weather is of thunderstorm or things like that, there are higher chances that there might be delay in a particular airport, or maybe the traffic of the aeroplanes itself is pretty much high, because of which there might be an impact on on the flight schedules in a particular airport. Based on this, the business leaders can allocate resources efficiently, can make business decisions, and improve the customer experience and ensure that the flight delay is reduced significantly. Okay, this is an example of an airline flight delay prediction. Another example, this is something similar even in PayPal, financial fraud detection. Okay, here we want to identify fraudulent transactions. So as a financial system, we always ensure that the transaction which happens across our platforms is for legitimate reasons and not for any unethical things or for fraudulent reasons, right? All those we would like to detect it and block such transactions. Okay, so how do we do it? We collect transaction related data and we clean and normalize the transaction related data. Then in the next data pre-processing phase, we try to handle missing data, detect outliers, do some hypothesis testing, and do feature engineering again on transaction patterns, things like that. Then create models. Okay, train fault reduction algorithms, employ machine learning techniques, then build visualizations, display fraud transaction performance metrics, and we can also visualize suspicious transaction patterns, from which region this is high, the traffic for fraudulent transaction is high. Then we can ask the business leaders to look into that and identify strategies to prevent fraudulent transactions. Okay, which will ultimately improve our customer trust, and for a business, as we will be reducing the fraudulent losses. Moving on to the last case study, which is retail sales analytics. Here, the problem statement which we have at hand is to optimize sales strategies. So, how do we do that? Again, it has to start from the data collection and data ETL. So here we will load the sales related data, the product related data, then the time frame related data to a centralized repository. Then in data pre-processing and EDF phase, we again remove duplicates entry. We handle inconsistent data. We remove data which we feel is not relevant to our business, things like that. Then on top of that, we do feature engineering, create features for product categories. So in such a data, there might be various product categories, correct? So in those cases, we create features for product categories and generate time-based features. Then perform modeling on top of that. Apply sales forecasting modeling like time series algorithms or things like that. Then visualize the sales over time. Create dashboards for product performance. Then during insight generations, we identify the high performing products. We try to optimize inventory management. All these will ultimately result in improved sales strategies. Also, we'll try to come up with reward programs or targeted marketing strategies for the customers who frequently use or who frequently visit this particular retail store, things like that. Correct. So ultimately, what this would result is increased sales or profitability. So I have covered some of the real life case studies here, but one call out I would like to make here is it is very problem statement specific. It is very important to be in constant touch with stakeholders who are giving the problem statement. Sometimes this is also important. They might have given the problem statement and we might need to go and revisit the problem statement. We really think solving this problem statement will help us to get the desired outcome? So it is not that just because we have got the problem statement we can start working on it. We will have to reiterate. We'll have to work with the stakeholders to retune or redefine the problem statement, to see if that would really will bring out the expected outcome. Okay. Then at each phases, right from data pre-process, right from data ETL to data pre-processing phase, right? It is very much important to be in constant touch with them. Maybe they will have some just business justification for an outlier data, which we might not be aware of, right? In those cases, we cannot blindly delete that particular record from our data tables. So we need to constantly get feedback and constantly show our progress, and tell our thoughts with the business stakeholders. It even during modeling phase, right? Like tuning the algorithms and deploying whatever we create. We first deploy it in our test environment, and then move on after completing successful user acceptance testing and all. Only then we'll be moving into production environment. Just calling out, for this entire journey, we need to be in constant touch with business stakeholders, get their continuous feedback. And this process itself can be iterative. It's not that once EDA is done, after going to modeling, it's not that we'll not come back to EDA. We might come back to EDA, right? And also, as I had initially called out, this is not one journey which will be true for all the problem statement. This will vary for each problem statement. Some problem statements might not even require modeling or feature engineering. They might be just they may be just wanting to see a descriptive analysis of what had happened in the past and predict something for the future, things like that, right? And Yeah, with this I have completed. Thanks for giving this opportunity. I will open the floor for Q&A if there are any. Florence or Vignesh, do we have any questions?
In the chat, no one has posted so far, sir.
Sure, no worries. All right. So I hope this session was helpful for each of you. Once again, I would like to thank PayPal, IIT Madras for giving this opportunity. Let us keep upskilling, and let us continuously learn things which we have not. Which we have not used so far. Okay. Let us leave the session with the mindset that we will continuously keep learning and we will continuously keep upskilling, and whatever we learn we'll try to implement in real life cases as as possible by us. Okay. Thanks everyone. Thanks once again. Florence, are we done or?
Yes, sir.
Okay. Can I leave?
Yes, sir, you can. Thank you
If,
so much. It was very good.
yeah, thanks, Florence. How many people dial in, Florence? Any idea?
That actually just now Vignesh sir left.
Okay.
Might be he will tell you regarding that. So
Okay. 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 All right. Thanks, Florence.
thank you, sir. Thank you.